So today we're going to talk about modeling with exponential functions in particular. So the first thing we're going to do is look at some examples, talk about the format of the equations, and then we'll do some problems in the next video. And there'll be a couple videos, one doing growth and one doing decay. So our first objective is just modeling the exponential growth or decay. We need to be able to solve for the rates. So in these problems, they're not going to tell us what the rates are. Just like in real life, if you really were trying to figure out what the exponential growth was for something, nobody would tell you what the rate was. You would just have some data for certain times. So in 1 year the population's this much, maybe in the next year or the next few years you have some data on that, and from that you're going to have to figure out what the growth rate is, and then we're going to write an equation that models that data, and then we're going to use that equation to make predictions for the future. This is going to be your mastery ticket. Take a second, read it over. Okay, so exponential and growth decay models. The mathematical model for exponential decay is usually given in the same format. You have some final amount that is dependent on t, and that's going to be equal to some initial amount. So that A naught, it's called A naught, is the initial amount. That 0 indicates the amount that we start with, or the amount at time 0. And then we're going to be using base E here. So just remember that's Euler's number, and it's actually a number. It's 2.71828, blah, 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 some other decimals. And just remember you can get that in your calculator. And then we're going to have the exponent k, which is going to be our rate in decimal form. So any percentage, make sure you write it as a decimal. And then also t is going to be in that exponent too. And t could stand for years, or sometimes it stands for days or weeks or whatever. It depends on the problem and the context of the problem. So generally if k is greater than 0, so a positive number, that's going to mean that we have growth, exponential growth. So our numbers will be going up at a certain rate. And then if k is less than 0, so a negative value, that means that our function is going to be decaying. So the amount's going to be decreasing. And then below here are just some graphs indicating those two things that could be happening. Here's a procedure for modeling exponential growth or decay. First we're going to use the model some future amount equals the initial amount with base E raised to the rate times the time. So we could be using k here, or you can use r. It's just sort of convention to use k. Enter in the known information into the formula. So they're going to give us some data about some starting amount and some later amount. They're not going to tell us the rate. Okay, so what we're going to do is plug in the values that we know, usually A naught, or the initial amount, and some final amount, and the time. And then we're going to have everything known except for k. So we will be solving for the rate, and we know how to solve exponential equations now. Next, we're going to, once we find out what our rate is, we're going to write our model for that situation. So in that case, we will just have A equals, so some later amount is equal to some initial amount that we'll have plugged in with our base E, and then this time we'll actually have our rate plugged in for k, and then t will leave as a variable. That way people can use it to find out or make predictions for the future. And then lastly, if the question asks us to make a prediction, we'll use the model that we found in order to make that prediction.